Hi, my name is Dongchan. Chan, please call me Chan. And I live in Seoul, in Korea. I am working as a MySQL DBA at KakaoBank, one of the major internet bank in Korea. I have been as a DBA for almost 11 years. And before DBA, I developed the web services for 5 years. My final goal is building an unbreakable data system. Hmm, It has been 4 years since the KakaoBank has opened. KakaoBank was noticed using open source database MySQL in banking service because there was no reference using MySQL in banking service in Korea. Many people worried about using MySQL, but we still don't have any failure with MySQL against the monster traffic for 4 years. 4 years, there were no failure. I and my team are very proud of this. The reason I'm here today is to share my experience. Today's session is called the Flexible Data Transfer Uldra-Replicator. As the name, I aim to do real-time migration of data in a flexible form. The agenda is as follows, and I will start now. There are many ways to transfer data in real time, but I would like to pick just two main things. The first is the migration using SQL, and the other one is the migration using CDC. Both they both have their own pros and cons. Let's talk about the transfer using SQL. As shown in this figure, data is migrated since the last migrate timestamp. It is very flexible because it pulls data from the query. But there's some problem. First, it is very difficult to handle delete data. And this is another terrible issue. Data loss could be because of the delayed commit. For example, consider a system that transfers data every 10 seconds. But suppose that in a specific transaction, it commits data change after 1 minute. As a result, the data will be lost. Second is using CDC. CDC usually utilizes the database's read log. There is a transaction history contains the changed history. In the case of MySQL, it is not a read log, but there is a binary log. Based on this, data recovery or data replication is performed. MySQL replication could be also kind of CDC, I think. There is no delete issue or no delayed commit issue because the data change history has been used. But CDC is a solution, so we need to manage replicate position. And the target could be limited a little bit. It could be very difficult if you want to transfer data to sharding database or the target is caching memory system which is not support from CDC solution. That is why the reason Uldra-Replicator has been started to serve these requirements with flexibility. As you noticed, Uldra-Replicator is a kind of binary log parser. Data processing starts after passing binary log. So let me explain about binary log in advance. Binary log is the log's change data history when a transaction is commit. It guarantees transaction order and it is confirmed from source database. There are a lot of events in the binary log, but there are few events meaningful to me: query, table map, write row, update row, and delete row event. The row format binary log consists of this structure. When transaction is commit on MySQL, the begin statement is entered as a query event, and the transaction is finished with an XID event. Then a table map event comes in, then followed by information about the data that is actually changed. If a single query affects multiple rows, the event comes in like an array after table map event. The table map event has the database and table name, and the column type information are also included. The important thing here is the table ID. Table ID would be changed if the schema is changed with alter. On the other words, you can check the table structure has been changed or not by checking this table ID. Another important thing here is that column names are not included. Of course, there's some option to enter the column names in binary log from MySQL version number 8, but the column name is not included until 507. So you have to check whether the table ID has been changed or not and get some information from the database. This is the write row event, and it is after the table map event. This includes the inserted row contents. This is sample in JSON format. This is the update row event. In this event, both the image before the change and the image after the change are included. Here, the update row event is recorded differently depending on the binlog row image, full or minimal. In case of full, all column contents before the change and all column contents after the change are recorded. In the case of tables with a large content size, if updates occur very often, the binlog would become very big size. When the binlog row image is minimal, only the changed column is recorded in the after image, and only the primary key of the changed data is recorded in the before image. But you cannot check the before or after of the change from this event. Of course, the size is small. This is the delete row event. This event is also recorded differently depending on the binocle log image. First, if it is full, all the contents of the deleted data are recorded. This can be very useful that you can track which data has been deleted. Of course, the size will be increased. On the other hand, in the case of minimal, only the primary key of the actually deleted data is recorded, so the log size is small. So far, I have roughly explained about the binary log. As I mentioned earlier, Uldra-Replicator is a binary log parser, and all processing begins from parsing binary log. So, and let's take a look at the flexible data transfer Uldra-Replicator. Uldra-Replicator targets three items: easy, performance, and consistency. Uldra-Replicator is a Java program, and binocle parsing is done with the MySQL binocle connector Java library. And in the sharding processing part, the sharding sphere is used. This is the overall architecture. First, parsing binary log from source database and make the data into hash map data, and then classify and put the data in a blocking queue. Then a query is generated according to each requirement and then thrown to data source. It would use sharding sphere if the target is several databases. It must be in raw format to use Uldra-Replicator, and I do recommend binocle format full image for flexible data processing. I mentioned earlier, Uldra-Replicator calls for easy operation. The binary log is the content of the database changes recorded in the order in which they are commit. Binary log is the result of the data that has been confirmed from source database, and the result you can trust. In other words, it is finally changed to the correct data if you replay the binary log. Even though there is some problem with the server in the red color of this figure, if the data is processed before the problem point, the correct data will be as a result. This is why it is possible to manage loose replication positions. For this, each event is converted into this form. Recover means period for recovering data. Therefore, when a data duplication problem occurs, it is skipped naturally. This is because the currently saved data at target database is the result, and the binary log from source database is the past data. When the group key is changed, first the data is inserted into the new group, and then old group data will be deleted automatically. I will explain what means a group key later. If we apply data in a single thread, you don't have to worry about this, but parallel processing is essential in order to process thousands of queries well. There is one point to note here. Using each person interest others' data in your service. That is, let's define group key ID in this figure, then perform parallel processing for each group. In this figure, data is processed by 3 threads and categorized by color respectively. And consistency, same group data, sequential processing is the key. Consistency can be guaranteed here in this part that the same group is processed sequentially. If you see the blue number, blue column, data from binary log events are applied sequentially in the order of the transaction. In other words, it is not necessary to consider the order of other color changes, but only the data that I needed to see guarantees the transaction order. Finally, transaction management. When there are multiple changes in a single big transaction, the transaction is divided for each individuals as shown in this figure in order to guarantee the individual transactions. Okay. This is the rough explanation of the Uldra-Replicator, and I will show you some example. Compile as shown in this figure and start Uldra-Replicator. Very easy. The first is to divide the data and replicate it to the target. I put the test example at this address. You can check. One single table is divided into 2 or more tables. You can configure it like this and start Uldra-Replicator. You can see that one binlogo policy has 2 replicate policies. And when I execute this insert queries, the result is finally like this. Okay. The second one is case of merging data. I also put the example at this address. You can check. From multiple tables on source database would merged into single table on target database. You can configure it like this. Here, the as user and as user status tables are combined into T user all info. First, let's execute the same insert query as before I used for the as user only. Then only the columns we set before is entered into the target table. The target query is generated with the onDuplicate key update. In addition to this, let's put the data in as user status. Then you can check that the finally columns is well stored in the target table. If we update 3 rows, you can see the login count has been increased by 1 as shown in this figure. Uldra-Replicator can carry data into sharding databases. This example is also in this address. You can check on this page. You can see the several databases in configuration. In this case, sharding sphere data source is created in this order. Basically, the sharding key is set based on the group key, and if there is no group key, it is classified as a broadcast table, and queries are transmitted to all shards. And when I execute these insert queries, the result is finally displayed like this. You can check the data is well stored in each shard. I separate the data from source table to truth table. Last one. This is the case of changing data on the streaming. Check this URL also. In this case, it can be solved by implementing a handler inside and write down the class name in the configuration. The interface of this handler is like this. In method, you can define things to be done during initial class loading, and in modify method, you define your code. This is the example combines the values of name and address into single column. All queries are made based on the hash map data. It is included in binlog operation object. So if you control the hash map data, you can change the data values in any way you want. For example, encrypting some specific column. If you create a class like this and specify the configuration file in row handler class name like this, then start the Uldra-Replicator and execute the same insert query like this. And finally, you can see that the new name value is finally delivered as defined. This is the description of the flexible data transfer Uldra-Replicator. Uldra-Replicator performs the binlog parsing and data conversion at the same time. It works overwriting for each operation, and data is grouped to the parallel processing for performance. And the same group process sequentially for data consistency by dividing large transactions into small transactions for each user. It induces no problem in transaction processing for each individual. In addition, it is possible to flexibly divide or merging data. It is also possible to transfer data to shards in real time. With the reader implementation, It is also possible to process the data into a desired form and process it for streaming. I put the base code on this Git. Yeah, this is a simple prototype toy project that needs a lot of improvement. And since this is just to solve my problem, it is not a project to be able to solve all of your requirements. I came here to share my ideas and what is your problem that facing with. And in the end, I want to do some auto scaling with the Uldra-Replicator, and I can use LoadSphere, uh, my another personal project to uh, initial data loading. Thank you.